In this video, we introduce and discuss the concept of a view in SQL Server and SSMS. Remember, the views are stored in your database on the SQL Server computer, and they are edited and manipulated through SSMS. SSMS is your client that runs on your desktop, and SQL Server is your database engine that runs elsewhere, locked in a closet or in the cloud. And the views exist right alongside your tables, the data in your tables, the permissions, the logins, the users, all the objects stored in the database. At the end of this slideshow, there are some table creation scripts. If you aren't able to create those tables on your own, you can download this slideshow from Blackboard, and you can create the tables that I reference here in the presentation. A view is a select statement, of which you have written many in this course, in the prerequisite course. A select statement that has a name and is stored in the database. A view is useful and effective for restricting the columns and potentially the rows that can be viewed from a table or a combination of join tables. And a view can become the underlying data source for a web page, a desktop app or mobile app, or any user interface that requires information from a database. When you create a view, chances are you will not be using it. You will probably be creating it for someone else, and they will integrate it into their application, into the user interface of a program they are writing, or into the business rules or the middleware of a program they are writing. As a DBA, database administrator, a database manager, you may be responsible for generating views, and then you'll never see the end result of those views. You'll never see how they're used, but you're responding to data requests from other people in your company or outside of your company even. And because you have knowledge of the schemas and how the data is stored and represented in the database, you're a good candidate for writing those views. Here's some best practices. When you are writing a software application that accesses a database, don't read directly from tables. Always go through a view. Even if the view looks simple, even if the view just grabs a couple of columns, doesn't do any sorting, filtering, grouping, aggregating, ordering, read from a view. The reason for this is because the table may change, the name of the table, the design of the table, the column names, and if all that changes, all we need to do is rewrite the view. We don't need to rewrite your code, meaning you may impact millions of people by changing the name of a table if the applications they're using directly reference the table. Use a view, even if it doesn't look like you need to use a view. Second bullet point, it may seem like it's easy enough to read from the table, still use a view. Third bullet point, when you write the view, don't grab the wildcard in your select statement. Don't grab blindly every column that will ever appear in those tables, because you don't know what's going to be added to those tables. And again, by using the wildcard, you don't know the column names, and those column names could change, and that would impact in a negative fashion all of the software applications that use that view. Stay away from the star. We use the star in class. We use the star in our sandbox just for a quick and dirty way to grab all the information from a table, but in practice we would not do that. Also, when you use the star, you are creating a lot more use of bandwidth than you might intend, because you don't know how many columns could be in that table, and you might be transmitting more information across your network than you need to do, which over time will just put an unnecessary burden on your network. Here's an illustration. Don't use the star. Select star from tbook, saying I want every column, and in this case every row, from the book table. In and of itself, it looks fairly simple, it looks harmless, but you don't know what the columns are. More columns can be added to that table later as the database evolves, and that query will grab up those new columns. You don't know what those new columns are. They could contain sensitive data, and you could really compromise the integrity of your system by making this wildcard available to anyone who wants to call this view. We use the term data request to describe what has been asked to be delivered from the view. This data request is what ISBN numbers are on file. As the DBA or the database manager, the database programmer, you might be asked to write a view to answer that question. And a good answer to that question, a good view, is on the slide. Select ISBN from book, order by ISBN. We don't even need the order by. It wasn't requested, but we threw it in. We did not add any data from the table. We did not add any columns from the table that were not requested. That way, if the book table has a sensitive column, perhaps the author's home phone number, or the wholesale cost of the book, or information that doesn't need to be revealed outside of the company, you don't use the wildcard, because you could be exposing that information to bad actors, and this is a violation of best security practices. Here's another example. In this case, we have a customer table. This is hypothetical. The customer table has a customer number, a name of the customer, and their address. The data request says what names, numbers, and addresses are in Ohio. So we form a filter, writing a where clause, filtering by Ohio, and in the select clause, we provide customer number, customer name, address, city, state, and zip. We do not provide anything else. We do not use a wildcard. We do not blast all of the columns out through the view, because we don't know what's in that table, and we can't possibly know what will be in that table in the future. We can write DDL, data definition language, in SQL Server to create views. Here's a simple example. We're creating a view called vbook. We use v as our prefix for views. And then we paste the select statement that we've already debugged and written somewhere else into the script. We run the script with a go, and we get a view. Very easy to do. This can also be done with the view designer in SSMS, which we'll do in a few minutes. But you know now that DDL can create a view programmatically, and hopefully you're realizing that everything we do in SSMS we could do in DDL if we really wanted to. Once you have written the view, you can use that in your select statement as a target. Instead of reading from tbook, instead of reading from the book table, we can read from the view. And this is a place where it's okay to use the star, because we've got some control over what shows up in the view, and we expect people who use our view to shotgun all the columns if they think that's necessary. So we have to anticipate that somebody is going to do a select star from a view without thinking, because they want everything that's in the view. So this is perfectly okay, because the target of the view, the target of the select statement is a view, not a table. So the star The wildcard in this case is okay. We use views to hide sensitive data. As we have discussed, we can prevent columns from being exposed in the table. We could prevent rows from being exposed by using where clauses and other filters. And that allows us to reduce the amount of data transmitted over our network. And that's a huge deal. I mean, networks become more and more clogged every day. And if we can send less data across our network, we can make the network more efficient for everybody involved. And you never know, there may be some networks that this data goes across that are charging by the bit. Radio, telephones, satellites. And if you can keep that bandwidth as limited as possible, you will save your company some money, and you'll certainly save some time transmitting that data. We also use views to abstract the underlying tables. That's why we use the aliases in the view. And you should have learned something about aliases in the prerequisite for this class. We use the as clause to alias the column names, and we use the as clause, or we use some other syntax to alias the table names. And by doing that, if the table name changes or the column name changes, we don't have to rewrite everybody's code that used the view. We just have to tweak the view a little bit, and we're good to go. From a practical perspective, if you look at the eBay, you drop down the categories list. That is probably generated from a view on the server side. There's probably one or more tables on the server side database. They're joined together in a SQL statement, and then that is written into a view. That view is executed by the coder of the web page. There's probably some code behind this. There's C# or PHP or Ruby or some other programming language. That view is executed. The results returned from the view become the rows in the drop down. Now there's no way to know for sure, because all we have at this point is the HTML, and we can't tell where it originated. But it's a very safe guess that there is a view backing the generation of that data. It's unlikely that they hard-coded that data into the HTML, because that would be problematic to make changes. It's much more likely that it's stored in a table somewhere. Who wrote the view? Probably someone who didn't write the HTML. Probably separation of responsibilities, separation of concerns. And it's probably true that the person with the creative skills and the HTML and CSS layout skills is not the person with the database knowledge. And it's probably true the database knowledge person wouldn't have a clue how to create a web page. Another example, this is the code or some code that is written to access information from a database. I'm not going to go over it line by line, and it's well beyond the scope of this class to teach programming. But you can see the highlighted line of code looks like a select statement, and that select statement references a view. What we would do to think this through completely is we would configure our SQL Server database such that the programmer who wrote this code could not use the table. They would not have permission to read whatever tables were combined together to create this vProduct view. And it's a safe bet that whoever wrote this code probably wouldn't have the database knowledge to do it anyway. So some kind soul on the database side built the view, provided that view to the coder that wrote this code, and that coder simply referenced the view when they wrote the program. Again, separation of concerns. The person that wrote this code does not need to know all the tables that were joined together to get this information. They just know they need to call the view, and they're good to go. If the view has a bug in it, we fix the view, and if we did it right, we don't break this code because it still works the way it originally did. In the View Designer, we have a three-way go, which is very useful. We can edit visually the three tables. We can edit by columns. And we can go down to the bottom if all else fails and we get really bored, and we can just type in the SQL statement. A change made to any of those editing modes affects the other two and automatically updates the other two. So I am going to go to SSMS. Hopefully you are logged in. Hopefully you have run the scripts at the bottom of the slideshow. And you have the three tables, pizza, pizza topping, and topping. Hopefully those scripts ran successfully. Don't forget to change the use command at the very top of the script to reference your database, not mine, because you cannot create tables in my database. But if you ran that script and you created those three tables, you can now make a view. Right click on the view folder, new view. You get the add table dialog. If you are ready to roll and you know what tables you need in the view, you can add them from the add table dialog. And if you need to add more tables later, you can always recall the add table dialog to put the tables in. I know I need these three tables. I need pizza, add, pizza topping, add, topping, add. Close the view, close the add table dialog. Notice the awesomeness of the SSMS View Designer. It automatically built joins. If you're like me, you like these things to line up in straight lines. It knew to join the tables because we built foreign keys into the design of the tables. If you look at the pizza topping table, there's a foreign key. And the foreign key says we are connecting toppings and pizzas. This foreign key says we are connecting toppings and toppings. Actually, we're connecting the intermediate table with these two other tables. And it's really cool because it did it for us. Now, if this wasn't here, we could remove it and then we could drag pizza ID onto pizza ID and accomplish the same thing. So if you forgot to create a foreign key in your table design, but you know that it's there, you can drag from one primary key onto the foreign key, or even drag the other way and it works fine. And then in the columns, all we have to do is hit the checkbox. That tells SSMS, that tells the query designer, we want that row, that column in the output of our view. I want pizza and I want topping. Notice as I hit those checkboxes, it also adjusted the SQL statement at the bottom. So that's our three-way go. We can edit any of these panes and the other two panes will automatically update. If we'd like to sort, we can add a sort here. We can change the sort order if we want to sort by pizza, and then inside each pizza sort by topping. We have the sort order set up correctly. We can add a filter if we want to filter on a particular pizza value or particular topping value or both. And our grand result is this beautiful select statement written down here. When we're done, we click the save button, but we're not done yet because we haven't even run it. So it's kind of sad to think about saving it without testing it. Execute SQL. I right click in the pane, execute, and there's my output. Is this right? Well, without studying the data you wouldn't know, but I encourage you to do some sanity checks on your data. Make sure that it looks reasonably correct. There are very few rows in these tables You should not have any problem matching foreign keys and primary keys to verify your results. When you're ready to save, click the Save button. We use V as our prefix for views. I do, and I'd like you to do the same. Click OK. You're going to get a warning about the order clause. Don't worry about it. It's just a warning. In the Views folder, there's the view I just created. And it's there for all eternity. You can give that name to your developers. They can use it to develop their web pages and user interfaces and desktop apps and mobile apps. And now they have access to only what they need in those three tables. They don't have any of the primary keys. They don't have any of the foreign keys. They don't know the schema. They don't know it took three tables to get the results of that view. And they shouldn't. They shouldn't know. So that's really good, and that makes our work much more portable and efficient. If you go online and look for naming conventions for views, you will find many. Some people use a suffix, some people use a prefix, some people use the entire word view. It's not a religious issue for me. I strongly encourage you to be flexible with whatever company you work for. Use their convention. You are expected to be flexible in my class and use my convention. But don't go to the wall on this issue. Be consistent. Go along with your team. And if there is no convention, subtly and persistently suggest they adopt some conventions, because you will be a lot happier with conventions. If you let people name things any way they want, guess what happens? People name things any way they want. And over time, that cannot be good. We're working together. We have to work together. We can use a view as a data source for another view. So instead of joining tables together, we can join tables to views or views to views. Here is a view that I've created that is simply only the animals in the animal attack database that are not regulated by the government. Now, you have the animal attack credentials on Blackboard. They will not be repeated here for security reasons. You are encouraged to go to the animal attack database, log in with those credentials, and follow along here. But I'm just illustrating the fact that I can create a view, and I'm going to use it as the data source for another view. Note the name of that view because you're going to see it again. The name is Pets Not Regulated. That's fairly descriptive. And in the next slide, we have used the Pets Not Regulated view. Join that with the Pet Attack Intermediate table. Join that with the Attack table to get a view that tells us the pets, the dates of attacks, and the types of attacks for all the pets that are not regulated. And we call that view Attacks by Unregulated Pets. One view becomes a record source, or one of the record sources for another view. Perfectly reasonable. We do it all the time. I'm showing you here a partial list of views from not even a reasonably large database, a rather small database. And hopefully you can see that I've gone to some effort to descriptively name these things. Find out what your company's conventions are. Do they want you to camel case? Do they want you to use a V prefix? Do they want you to use a suffix? Do they want you to use underscores? Do they want you to use spaces? Gag? I hope not, but some places will let you put spaces in these names, even though I don't think you should. If you'd like some extra credit, research why database objects should not have spaces in their names, and write me a report. You will find all kinds of opinions, and I would like you to show me both sides of the story and then give me your opinion at the end, because as a developer you're going to run into different opinions on how things should be done. It's good to be prepared to discuss those different perspectives. That brings us to the end of this amazing slideshow. I encourage you to run the scripts if you haven't and experiment with creating views. And please let me know if you have any questions. Thank you.